Hello everyone. Today we're diving into a crucial concept in modern software architecture, the Saga Design Pattern. As applications become more distributed, especially with microservices, managing transactions across multiple services becomes a significant challenge. The Saga Pattern provides an elegant solution to ensure data consistency in these complex environments. At its core, a saga is a sequence of local transactions. Each local transaction updates a database within a single service and then publishes an event or message. This event then triggers the next local transaction in the sequence, potentially in a different service. Think of it as a chain reaction, where each successful step moves the overall process forward. In traditional monolithic applications, we rely on ACID transactions to ensure atomicity, consistency, isolation, and durability. However, in a distributed microservices environment, a single global ACID transaction spanning multiple services is often impractical due to performance overhead and tight coupling. If one service fails mid-transaction, how do we ensure the entire system remains consistent? This is where compensating transactions come in. If any local transaction within a saga fails, the Saga pattern dictates that a series of compensating actions must be triggered. These compensating transactions effectively undo the changes made by previously completed local transactions, bringing the system back to a consistent state. It's like having an undo button for your distributed operations. There are two primary ways to implement the Saga pattern: orchestration and choreography. In an orchestration-based saga, a central service, often called the orchestrator or saga coordinator, takes charge. It defines the sequence of local transactions and sends commands to each participant service. The orchestrator maintains the state of the saga and is responsible for executing compensating transactions if a step fails. This approach offers clear control and easier monitoring, making it suitable for complex workflows. Conversely, in a choreography-based saga, there is no central orchestrator. Instead, each service participates by producing and consuming events. When a service completes its local transaction, it publishes an event, which then triggers the next service in the saga. This approach promotes loose coupling and autonomy among services, but can become challenging to manage and debug as the number of services and events grows. Let's consider a common e-commerce scenario: placing an order. When a customer places an order, it might involve several services: the order service, payment service, inventory service, and shipping service. Each of these performs a local transaction. If, for instance, the inventory service fails to reserve items, the saga would trigger compensating transactions. The payment service would refund the customer, and the order service would cancel the order. This ensures that even with failures, the system remains consistent. The saga pattern ensures eventual consistency, even in the face of failures. It provides high availability by avoiding long-lived distributed locks and allows services to operate independently, facilitating horizontal scaling. While powerful, the Saga pattern isn't without its challenges. It increases complexity in designing and implementing sagas, especially compensating transactions. Tracking the flow and debugging failures across multiple services can be difficult, and there's a lack of immediate isolation, meaning other transactions might observe intermediate states of the system. In summary, the Saga Design Pattern is a vital tool for building robust and consistent distributed systems. By understanding its principles, the two implementation approaches, and the role of compensating transactions, you can effectively manage complex workflows in a microservices architecture. If you found this explanation helpful, please give this video a like and subscribe to our channel for more insights into software architecture and design patterns.